Welcome to the video lesson on rationalizing radical expressions for whenever there's a radical in the denominator. So first of all, what does rationalizing mean? Well, we said in class that you can't have a radical in the denominator of an expression. The way to correct that is to multiply both the numerator and the denominator by the same thing. Specifically, that thing is the expression that makes the denominator a rational value, so not a radical. In general, how to get rid of a radical is by multiplying the radical by itself. So, for example, root 5 times root 5 is equal to root 25. And we know that root 25 is reducible. 25 is a perfect square. Root 25 is equal to 5. Root 7 times root 7 is root 49. And we know that root 49 is reducible. It's a perfect square. That's equal to 7. In general, we can just skip from this step to this one and say that when you multiply a radical by itself, you end up getting whatever expression is inside the radical sign. So root 7 times root 7 is 7. Root x times root x is equal to x. That's important because when you're going to simplify an expression, you'd start up by reducing the coefficients, next reduce the radicals, and third step, if you have a radical in the denominator, you have to multiply both the numerator and the denominator by the same thing, and that thing is the radical in the denominator. Let's see an example. 1. We have coefficients, 5 and 2, and radicals, root 8, root 4, in the same expression, step 1. If you can reduce the coefficients, you should. Here you can't. Step 2. If you can reduce the radicals, you should. Radicals can be reduced in a few different ways. One is that you could reduce each individual radical. 8 is equal to 4 times 2. Another way is if you have a radical on top and the bottom, you can divide those two. 8 over 4 is reducible to 2 over 1. And you don't have to include the 1 because root 1 is just 1. So root 8 over root 4 is equal to just root 2. And now we don't have a radical in the denominator, so we're done. In the next example, coefficients and radicals, we'll go through and simplify each one. Here, the coefficients 4 over 5 can't be reduced. The radicals, root 8 over root 3, can be reduced, but not because they have a common factor, only because 8 is reducible as a root. 8 is 4 times 2, and 4 is a perfect square. So this ends up being equal to square root of 4 is 2, 4 times 2 is 8, 8 root 2 over 5 root 3. Next, because there is a radical in the denominator, we need to multiply the top and the bottom by the radical. You'll always pick the expression of the radical in the denominator to multiply the top and the bottom. That's how you end up canceling out the radical. Here when I multiply, I would get on top 8 and root 6. And at the bottom, 5 times, we know root 3 times root 3 is just equal to 3. That ends up being 8 root 6 over 15. This is not reducible, so that's the final answer. Next example. I now have coefficients that are reducible. 2 and 4 have a common factor of 2. These radicals can also be reduced. 8 and 20 have a common factor of 4. So when I reduce this, this becomes 2 over 4 simplifies to 1 over 2. 8 over 20 simplifies because both 8 and 20 are divisible by 4 to 2 over 5. 8 by 4 and 20 by 4. Now there's a radical in the denominator, so I'll multiply the top and the bottom by the radical expression in the denominator, root 5. Root 5 over root 5. On top I get root 10, and the bottom 2 times 5, which is 10. This expression is not reducible, so that's the final answer. Finally, if you're dealing with variable expressions in the numerator or denominator, you go about things the same way. Here the coefficients 2 and 1 are not reducible. The radicals can be reduced, but not because of 5 and 3, because of the x's and y's. I can do x to the power 4 divided by x and y to the power 3 divided by y. Following exponent laws, that means subtracting exponents, and I end up with 5x cubed y squared in the radical on top, and only only root 3 at the bottom. This can be reduced as well, because root x cubed and root y squared are reducible expressions. Root of y squared is y, and remember that root of x cubed is the same as root of x squared times x. X squared comes out and becomes x, and I'm left with a root x inside. And now, to rationalize, I'll again multiply the top and the bottom by root 3. This is no longer reducible, so that's my final answer. That's it for video lesson 1.